All right, today we are looking at sets, inequalities, and interval notation. Main focus on inequalities. Specifically, what we want to do is determine whether a given number is a solution of an inequality. Write interval notation for the solution set or graph an inequality. Solve some inequalities, maybe try some word problems. First off, this is what an inequality is. It expresses a range of solutions to a problem. In other words, it's not like an equation where at the end you get x equals 2. In this case, it's a range of solutions. So you can say, well, yeah, 2 will work, but 3 will work, and 4 will work, and there might be a range of numbers that will work. For example, I want each of my 3 kids to receive at least $40. How much money must I have to make this happen? Notice that word at least indicates that there's probably going to be a range of money that I need. Here's how I might solve that. Whoops. So X is the amount of money I need, and it must be larger than, I guess it could be equal to, my 3 kids multiplied by how much money I have to pay them. So 3 times 40, of course, is 120. But notice here, the solution to my problem, X is greater than, we'll put an equal in there too, X is greater than or equal to 120, X could be a lot of numbers. Like X could be 120, that'd work. If I had $5,000, that'd work too. If I had $121, that would work. If I had $119, no, that one's less than X, so this one won't work. But there's a range of numbers that will work. And this is how I could express that range. Um, uh, when you express the range using interval notation, what you do is you start with the lowest number and write the highest number. And then you put a comma in between them. And then if it's just greater than, you put a comma. I changed that to an equal sign, so I need to change this side to a square bracket. Square brackets indicate an equal, either less than or greater than, or equal to. So I need to use a square bracket in this case. Lowest number, comma, highest number. And in this case, it's infinity. So that's the interval notation that I could use to express my answer. This reads, it can be equal to 120 and anything larger than that up to infinity or beyond. Okay? Careful with interval notation, because sometimes, like if this would have just been X is greater than, say, 50, if that would have been my answer, I would have said, okay, my lowest number is 50, and it goes all the way to infinity. And if it doesn't equal 50, if it's greater than, like 50 won't work, 51 will, but 50 won't, then I have to put a bracket like this and a bracket on this side. Careful with that, because that looks an awful lot like a coordinate. Usually the question itself dictates what it is, and you can tell the difference between them, but careful with that. Okay, so if I needed to plot interval notation on a number line, I can do that fairly easily using those same square bracket kind of things if I need to. This one here says it starts at, this would be negative infinity, and goes all the way up to negative 4. Is that how it is? Let me look at this. X is greater than or equal to negative 4. I don't think this shows that. Let's just check that. If X is greater than or equal to negative 4, the smallest number should have been minus 4, and the largest number would have been infinity. There's no equal sign, so I could put brackets on each. I think this one here is indicating this. All the x's as long as x is less than negative 4. That's what this one here is representing. That looks a bit confusing, so let's just get rid of some of that. Let's go with this latter one. So I'm not going to use this one, nor will I use this one. So I'm saying I can start at negative infinity and go all the way up to negative 4, but not beyond that. The bracket says it doesn't include negative 4 either. So I'm going to find negative 4 right here. If it doesn't include it, I put a curly bracket right there. and then draw my line going this way. And I can put an arrow at the end indicating that it goes on forever. Here's another one. Oh, I've got square brackets. Must mean that it includes them. So I start at -3, that's right there. So I'll put a square bracket at -3, a square bracket at 5, and everything in between there will work. So that's how I can graph that. Let's do this one just for fun at the end. Lowest numbers of -2, that's right there. A square bracket, so it includes -2. And it goes to infinity. I'll just draw my line going that way. That's how you can graph interval notations. Now to solve inequalities, you get to use the same rules as we do for solving a regular equation. For example, this equation, 3x minus 2, if I had said equals 7, I would add 2 to both sides, and then divide both sides by 3, and I'd have my solution. In this case with solving inequalities, I do the same thing. The same rules apply. So I'd add 2 to both sides, 3x is greater than 9, divide both sides by 3, and I would get as my answer, x must be greater than 3. Let's test that and just see. So let's pick a number greater than 3. How about 5? Let's plug a 5 in. So if I take the same equation, 3x minus 2 is greater than 7. If I plug a 5 in, the statement that I have here must be true. I'm plugging in a 5. I just picked that because it was bigger than 3. I could have picked 10. 3 times 5 is 15. 15 minus 2 is 13. So is this statement still true? 13 is greater than 7? Sure enough, works. If I were to try a number lower than that, let's try that. I'll do that right over here. Let's go 3x minus 2 is greater than 7. Let's pick one that shouldn't work, like 0. 0 is less than 3, so that shouldn't work. Let's plug a 0 in. 3 times 0 minus 2, is that greater than 7? 3 times 0 is 0. 0 minus 2 is negative 2. So is this a true statement? No, it isn't. Minus 2 is less than 7. Not a true statement. Therefore, 0 is not part of my inequality. Okay, so solving, I do the same as I do with solving regular equations. I guess the only one caveat with that is that if I ever have to use the multiplication or division principle, and if I have to multiply or divide all of the terms by a negative number, then what happens is the sign switches. So instead of being a less than, it becomes a greater than. So you just have to be careful with that. I think I have a question like that on this slide. So let's try and solve this one. Let's bring the 5x over to this side and subtract, so I'd have negative x is less than or equal to. Add 1 to both sides, so I have a negative 1. Now I need to divide both sides by a negative 1 to get rid of this negative. So if I divide this side by negative 1, I get x. If I divide this side by negative 1, I get a positive 1. But when I divide by a negative 1, I must change that sign. So that sign, instead of less than or equal to, now becomes greater than or equal to. And again, I could check that. Let's check it just quick. So let's check it with a number that's greater than or equal to 1. How about 2? So let's try 4 times 2 minus 1. Is that less than or equal to 5 times, 2 I'm trying, minus 2. Okay, so this should be a true statement because I picked a number that was bigger than or equal to 1. 4 2s are 8, minus 1 would be 7. Okay, I want to know if that's less than or equal to what I get over here. 5 times 2 is 10, minus 2 is 8. So is 7 less than or equal to 8? Sure enough. Yeah, yes it is. So that checks out. Okay, so solving inequalities, use the same rules as you do for solving a regular equation. The only trick is when you're dividing by a negative 1, and if you have to do that to all the terms in your inequality, you must change that middle equality. So it has to change from less than to greater than, or vice versa. One last question. Here's an interesting one where I might need some problem solving to solve this. I need some general repairs around the house. 2 handymen offer help with these payments. You can choose 500 plus $10 an hour, or a flat 20 bucks an hour fee. For what number of hours will the second payment be greater than the first? Oh. Second payment is 20 times the number of hours. Let's call that X. So for what number of hours will the second payment be greater than? Okay, greater than. It doesn't say equal. So second payment greater than, okay, 500 plus $10 times however many hours you work. I think that's right. Okay, so now I need to solve. I'll bring the 10x over to this side and subtract. So I'll get 10x is greater than 500. Divide both sides by 10, and I'll get x is greater than 50. Notice I didn't have to swap the sign because I didn't divide by a negative. So in order to, so if I'm looking at a job and I think that it is going to take more than 50 hours to complete, then I tell the guy, hey, 20 bucks an hour flat fee, that works good for me. If it's less than 50 hours, then probably this one would be a better method of payment. I think that's right. Yeah. Okay, so today then we've looked at inequalities, and we've looked at what they are, how to see whether a number fits in an inequality. We've solved some inequalities, and we've also done a quick problem-solving question with those. Hopefully that'll give you a hand in solving your homework questions.